have a look at these two maps and tell me, where do tectonic hazards occur? So use your place names, your plate names, and your plate margins to do that. Then tell me, why do tectonic hazards occur in these locations? So think back to what we did before about keywords and processes. And then as a challenge, is there anything you didn't expect? So where do tectonic hazards occur? They occur along plate margins. The majority occur along, by the looks of things, the outside of the Pacific Ocean, along the destructive margins through there. Why do they occur in those locations? Well, because of plate movement, plates moving together or plates moving apart. And there's one thing you don't expect. Well, there's one thing that would probably pop out to you, and that is this one, these volcanoes in the middle of a plate. So the islands of Hawaii, they are not on a plate margin, they're in the middle of a plate, and it's because the mantle is particularly hot there, so it literally melts the surface, melts the crust. Okay, so we're looking at tectonic hazards today. We're looking at earthquakes and volcanoes, where they occur, their key features, what causes them, and why are they different at different types of margin. So referencing the processes that are destructive or constructive to help explain why your earthquakes and volcanoes can be different in different places. So we're still here looking at the processes. We'll look at the effects next lesson. So a bit of a recap. 4 plate margins, what are they and which ones cause earthquakes? So this one here, this is your destructive margin, and that causes our largest earthquakes. This one here is our collision margin, so a type of destructive margin, still moving together, and they cause large earthquakes. This one is your constructive margin, so plates moving apart, constructing new crust. They do cause earthquakes, but only very small ones. And your conservative margin here, moving side to side, they also cause earthquakes. So all of them do. Now, we would have discussed this if we were in school, but let's have a look at this map here. The circles show the size of the earthquake, so how much energy there was, how much shaking there was, and then this map here, that map we've shown before, showing the different types of margin. Just be careful because the maps are different. So this one has us in the middle, this one has the Pacific Ocean in the middle, so we're actually here. So if you're looking at the type of plate margin, you need to remember that. So are all earthquakes the same? What do you think? Well, the answer is no. Some are bigger than others. And what you might notice is those largest earthquakes, they actually occur along our destructive margins. So look down here, South America, that's this destructive margin here. This huge one there, that's on this destructive margin between India and China. And then this large one here is on this destructive margin between the Philippine plate and the Eurasian plate. So that says that our largest earthquakes occur along destructive margins, and that's not a fluke, that's not coincidence. There's a reason for that, and that's what we need to think about. So we need to start with why they happen. I've got a quick video, I'll put that and show my homework for you. That'll just explain a bit about earthquakes, what they are, what they do. It'll also set the scene for what we look at later. And all earthquakes they're sudden or violent movements within the Earth's crust, and they're caused by the release of built-up pressure. This usually only lasts a few seconds, but can be followed by aftershocks, so smaller earthquakes, smaller bits of shaking afterwards. So there's 3 key features when an earthquake happens. You've got the focus, which is the location where the earthquake begins, and that's in the earth, that's underground. Remember, these plates can be 100 kilometres thick, so your earthquake can be right down at the bottom, or it can be right down up at the top. So the point where the earthquake starts within the crust is called the focus. The epicentre, and this is what you'll hear on the news, this is the point on the Earth's surface vertically above the focus. So in the news they might say the epicentre was just outside of Tokyo. So that's the point on the Earth's surface. The fault line, well, that's the break or a fracture in the ground that occurs when the Earth's tectonic plates move, and it's along that fault line that your earthquakes will happen. So draw yourself a version of this diagram. It doesn't have to be a work of art, and I want you to put on where you think these 3 keywords go. So which is the focus, which is the epicenter, and which is the fault line. So this one here, this is your focus. This one here, this is your fault line. And this one here, this is your epicenter. This is a paragraph that just explains why those earthquakes happen. I want you to write out the paragraph. You can print it if you like. I'll put the resource and show my homework. And then I want you to fill in the missing word. So for example, over 90% of earthquakes occur where plates are moving together at destructive margins. So you read through and you just fill in what those missing words are. The missing words, they're all here. So over 90% of earthquakes occur where plates are moving together at destructive plate margins or slide past each other at conservative plate margins. Where plates are moving apart, limited pressure builds up and earthquakes are characteristically low magnitude. Magnitude is the size of it. The movement of one plate past another is not always smooth, and sometimes plates stick as they move past each other. Intense pressure builds up and rocks deform so they can bend and twist under stress. As the pressure is released, there is a sudden movement creating seismic waves which radiate, so move outwards from the focus through the Earth's crust. A seismic wave is just the name we give to the wave caused by an earthquake. An earthquake's seismic activity, so the movement we call seismic waves. Shallow focus earthquakes are more dangerous than those with a deeper focus, as more power is unleashed closer to the Earth's surface. So make sure you've got the correct words written in to complete that paragraph. Now we're going to look at volcanoes. So look at these three diagrams and think, what do they show? So what is a volcano basically? How are they different? And why are they different? So look at the shape, look at what they're made of, look at the lava coming out of it. So you can see we've got our composite volcano up here. This is our cinder volcano, which we don't need to know too much about. And then we've got our shield volcano down here. So these are the two types of volcano we mentioned last lesson when we looked at plate margins. So what are volcanoes? They're basically where magma erupts on the surface as lava. How are they different? Well, they can be different shapes. They can be made up of different things. They can erupt in different ways. And the reason they're different is because it depends on what plate boundary they occur on. So now I want you to watch this video. I'll put the link on Show My Homework, and that'll just explain to you a bit more about volcanoes, what they look like, some of the key characteristics. So a bit more about those different types of volcano. Our composite volcano, sometimes called a strato volcano, and it's called that because it's made up of layers of lava and layers of ash. So every time that volcano erupts, you'll get a layer of ash deposited. Another eruption, you might get a layer of lava deposited and then more ash. So it builds up. So each layer is added to after each eruption, because when lava cools down, it actually solidifies into solid rock. And these typically, they're those like triangular pyramid shaped mountains that we all kind of think of when we think of a volcano. And these volcanoes, they're very explosive. So they literally go off with a bang. They explode. They're very, very violent. They tend to have quite wide bases, quite steep slopes. So it's pretty cool. They're quite good to climb. And not if it's erupting, obviously. And this one you can see here, this is Mount Fuji, which is in Japan. And it's one of the most famous volcanoes. You can see it from the city of Tokyo. And they can be up to 8,000 feet high. So they're huge, huge mountains that erupt. The other one is shield volcanoes, and they tend to be built up mostly of lava. But the lava in a shield volcano is quite liquidy, it flows quite freely. In a composite volcano, it's quite sticky. It's a bit like treacle. Whereas in a shield volcano, it's more watery. So it erupts, the lava spills out freely, it spreads a long way, and it creates these kind of gently sloping, domed volcanoes that look a bit like a shield. That's why we call it a shield volcano. So sometimes these can be up to like 50 kilometres apart. So the islands of Hawaii, they are literally made up of shield volcanoes. Each island would be one huge shield volcano. So that's your two different types. What I want you to do is you're going to draw a diagram for each. So you can use these diagrams here, or you can use these diagrams here. It's up to you. But then I want you to add these labels. So where is the crust? Where's the magma chamber? Which has layers of lava, runny lava? Which one has layers of lava and ash? Which is violent? Which is mild and frequent? Which forms on a constructive margin? And which occurs on a destructive margin? So use the definitions over here to help you. So your composite volcano is steep-sided, formed along destructive margins that are violent. Your shield volcano is a gently sloping volcano formed along constructive margins where eruptions are mild but frequent. So the reason your shield volcanoes are quite mild is at constructive margins, the crust is moving apart, isn't it? So it's moving out, that magma can rise quite freely and erupt, whereas on a destructive margin, that lava is from one plate being pushed under another, it's being melted, and that magma is being forced to the surface. Because it's quite sticky, it can block, it creates like a plug in the vent of the volcano, and the pressure builds up and up and up until eventually, bang, it erupts, it explodes. So now we need to go through and actually explain what causes earthquakes and volcanoes at these different margins. So you can draw versions of these diagrams if you like, or you can print them. But I want to use these key terms to explain what causes earthquakes and volcanoes at destructive margins, what causes them at constructive margins using different key terms, what causes them at conservative, well, earthquakes at conservatives margins using these key terms. So here are some perfect answers for your destructive. So you can see the pressure builds up, they fracture, oceanic plates subducted, that melts, that hot magma rises, erupts as a volcano. At constructive, magma rises, the plates move apart by ridge push and slab pull. Magma rises, forms solid rock, creates more oceanic plate, small and not violent. Much of the magma never reaches the surface, but it actually pushes the crust upwards, creating that ridge that we get along the middle of the Atlantic Ocean. Finally, your conservative. So pressure builds up at those margins. They become stuck due to friction. Eventually they give way, creating an earthquake. You don't get volcanoes because magma cannot rise to fill a gap, because there is no gap. No land is destroyed, there's no subduction, so no volcanoes. So finally, the two types of volcano are shield and composite. They form at, so shield are at constructive margins, composite are at destructive margins. The centre of the earthquake is called the focus. The point directly above it on the Earth's surface is called the epicentre. So finally, we have an exam question. I would like you to have a go at calculating the movement, and then I would like to upload an answer to me and show my homework, saying, using figure 2, this is figure 2, and your understanding, suggest how plate movements cause tectonic hazards in Iceland. 6 marks. Remember, pattern, not pattern, bucket, box, underline, glance, make a point, develop it using triggers. So submit your answer to this and show my homework, and write me an answer to this and show my homework, please. I will mark it, I will give you feedback, and then we'll discuss it when you're in school next week.